Which of the following is the graph of f of x is equal to 3 times the absolute value of x minus 4 plus 1? All right, so this is going to come from, again, our knowledge of our standard equation, our vertex, and how these transformations kind of affect that. So I'm going to go ahead and write out what the standard equation was, or is, which is a times x minus h, absolute value, not parentheses, plus k. So where my vertex is equal to h comma k. So looking here, my standard form is pretty similar to what the equation is given. So looking here, it looks like my values of h and k are going to be -4 and 1. So for us, v, or my vertex, is equal to +4 and 1. Now again, the reason why it's not going to be a -4 is because I'm only taking the value of h. And we can see here that the standard equation is written or given to us as a negative. So the only time that I would take a negative or have a negative h value if it was the case that this was a plus, like in our previous problem. But because this is minus and minus, I just take the value of h, which is 4. And then I can see h is, my k is 1. So let's go ahead and do a little bit of elimination of seeing which vertex or vertices I can already cancel out. So here, this is at -4, +1. Okay, so not going to work. Here, +4, -1. Okay, that was closer, but no. -4, -1. Nope. Okay, so that only leaves this last graph for us. Now, the only transfer or the other transformation we can consider is this 3. And if you recall from our notes, my function will either stretch or shrink depending on this value here. If this number is greater than 1, it is going to compress, meaning it's going to get skinny. If this number was anything less than 1 but greater than 0, so maybe like 0.5, -3/4, or just 3/4, then I would see my function get wider. So this is a 3, so that's why we can see here that my absolute value graph is looking a little on the slim side.